Okay, so this problem says you want to build a fence in a rectangular vegetable patch. The fencing on the east and west sides. Okay, so I don't see a picture, so I'm going to draw it for you. Um, North, south, west, east. Okay. Um, the fencing for the east and west sides are $8 per foot. So this side is $8, this side is $8 per foot. The fencing on the north and south are $4 per foot, $4 per foot. You have a budget of $96. What is the largest area that you can enclose? Alright, so the formula for rectangle for area is length times width, or how you defined it, it looks like you did x is the east. Okay, so this would be 8x, 8x, these would be 4y, 4y. So in this case, it would just be x times y. Perfect. Now, if you have $96 to build a fence, that is a totally different formula. You're not using area to build a fence, you're using perimeter, because your fence goes around the edges. That's where your mistake came in. This equation, your constraint equation, the perimeter of your fence would be 2x's, like length and a length, so 2x plus 2y, but they don't want it just in perimeter, we want it in money. So therefore, how do we convert these into money? Well, it's the number of feet times the amount per foot. So our $96 is going to be equal to 8 times 2x's plus 4 times 2y's. So therefore now our constraint equation would be 16x plus 8y equals 96. Now your substitution step or your Lagrange step looks fine. How you're doing it is good. Your partial derivatives look good, but then here's where your solving goes kind of crazy. You set them equal to 0, perfect. Do not solve for y. No. Solve for lambda. Always take one of your equations and solve for the lambda. So this equation here, now it's going to be easier to deal with because this one has a product because you miswrote your constraint equation. It's going to now have addition in it, so it'll be easier to solve for lambda. But nonetheless, you're going to solve for lambda. So I'm going to do it with your equation here. So here we would have lambda, lambda is equal to what? Negative y divided by, is this 32, what does this say? I think that's the derivative of this with respect to x. That would leave me with 832. Yeah, I think that 8's not supposed to be there. I think it's just supposed to be 4 times 8 is 32, 32y. So then it'd be divided by 32y. Those y's would divide, leave me with negative 1 over 32. Which means now in my next equation, instead of writing lambda, I'm going to write in negative 1 over 32. So this equation would become 0 equals x plus 32. I don't think that 4 should be there again because you already did the 8 times 4, so that should be gone. So it'd just be 32 times x times negative 1 over 32. Good news, those would divide. And the reason we're getting funkiness here is, again, because your constraint equation isn't correct. But nonetheless, you should be getting x equals something, and then you can substitute that into this equation, your third equation, to help solve for your answers. Okay, so as I warned you before, as I told you before, whenever you get your first three, you get your derivatives, you get your partials, solve for lambda, sub that in. That's step number 1. Don't solve for x and y. No. Start by solving for lambda. Okay, best of luck.